Hey everybody, in Econ 1B. Today I'm going to go over the midterm, talk about the graphing problems and a couple of the multiple choice problems that people had questions about, and hopefully clear up any questions you had so that you're finally 100% ready and done with all the material we've done so far. So the first thing I'm going to do is go ahead and do the graphing portion. There were two parts to it, a market demand and supply version, a part, and a production possibilities frontier part. I'm going to do it some on a Word document and some on the board. So let's go ahead and take a look. Okay, so here is the first problem. Consider the individual supply and demand schedules below. Sum the market supply and demand for cookies to get the market demand and market supply schedules. So that should be pretty straightforward, right? If we want to look at these three individuals who demand cookies and these two firms that supply cookies, we just go straight across and say, okay, so at a price of $0, Cerise wants 8 cookies, Aminette wants 5, and Rose wants 14. So that gives us a total of 17 cookies. On the other hand, the market is not willing to supply any cookies. 0 plus 0 is 0. So at a price of 0, market demand is 17 and market supply is 0. At a price of $1, Cerise, Aminette, and Rose all want a little bit fewer cookies. At that price, Cerise wants 6, Aminette wants 4, and Rose wants 3, giving us a total of 13. On the other hand, Toll House is now willing to sell 2 cookies, and Girl Scouts are now willing to sell 1 cookie. So that gives us a total market supply of 2 plus 1 equals 3. Next here we've got a price of $2, where now Cerise only demands 4 cookies, Aminette only demands 3, and Rose only demands 2. That gives us a market demand of 9. On the other hand, Girl Scouts and Toll House are both willing to supply more to the market. 4 plus 5 equals 9. And then as the price goes up, quantity demanded goes down again. Now 2 plus 2 plus 1 is 5. Market supply goes up, obeying that law of supply, right? Upward sloping supply curve. Now at $3, the market is willing and able to supply 13 cookies to the market. And then at a price of $4, Cerise wants 1 cookie, Aminette wants 1 cookie, and Rose wants 0, giving us market demand of 2, while the market supply is 8 plus 10, or 18. And we can see here now that our equilibrium price is going to be that $2, where quantity demanded of 9 is equal to quantity supplied of 9. So that is our equilibrium price and our equilibrium quantity. Now we want to go ahead and graph the supply and demand schedule and indicate that equilibrium price and quantity. So let's go ahead and do that. Okay, so now I want to graph my market forces of supply and demand. Some people did this on scratch paper by hand. Some people did it with a whiteboard function on their computer, or using the insert function with inserting shapes on Word. Whatever you did, as long as I could read it, that's great. And you want to make sure to label your axes with at least a Q and a P. And we have the market for cookies here. And our prices go from $1 all the way up to $4. And our quantities go from, market supply goes from 0 to 18, market demand goes from 2 to 17. So we can go ahead and, and put that in here. So let's say we've got 2, 4, 6, 8, 10, 12, 14. I'm going to need a little more space. 14, 16, 18. No, that's my quantity. And then we can build our demand schedule and our supply schedule. So the demand schedule is going to be based on market demand, which is very low when the price is high and high when the price is low, right? So at a price of $4, consumers want 2 cookies. At a price of $1, the market, as a price of $3, the market demands 5 cookies. So it's going to be right there. At a price of $2, the market demands 9 cookies. And at a price of $1, the market demands 13 cookies. And then finally, if cookies were free, people would want 17 cookies. So that gives me sort of stylized demand curve. You also want to make sure you label your demand curve, maybe not necessarily with the full word demand, but at least with that D, right? So then we want to go ahead and derive that market supply curve, and we're going to do the same thing. So we're going to see that supply curve be upward sloping because of the nature of the law of supply. So at $0, the firm doesn't want, neither firm wants to supply any cookies. And then when we go to $1, they're willing to supply 3 cookies. At $2, they are willing to supply 9 cookies. At $3, they are willing and able to supply 13 cookies. And then at $4, they are willing and able to supply 18 cookies. And that gives us our kind of stylized, a little bit funky, there you go, supply curve, which again, you want to label. And then we have our equilibrium price. So our equilibrium price is $2 and our equilibrium quantity is $9, or 9 cookies. And then the next part is to draw the effect of an increase on the price in the price of milk, which is a complement to cookies, and how that affects the cookie market. And if it's a complement, then higher price for milk is going to make the experience of having milk and cookies together more expensive. So that's going to shift the demand curve in. So you can shift it in however much you want. And I'm just going to label that demand 2, right? And you want to say something to the effect of, the price of a complement reduces demand. It's a non-price determinant of demand. It's going to shift that demand curve in. We're going to see price go down and the quantity, the equilibrium quantity go down. The last question asks, what's the effect on surplus, on consumer surplus? So we can look at it and see that consumer surplus before was the area below the demand curve and above equilibrium price. Now our new consumer surplus is going to be smaller, right? Even though the price went down, the demand curve shifted down. And so we're going to see the new consumer surplus be much smaller than the previous consumer surplus because of that shift in demand. Does that make sense? Hopefully? All right. Next, we're going to look at problem number 2. Okay, so for part 2, we have a production possibilities frontier problem. So it says a coffee shop has a total of 200 hours of labor per day to produce either cookies or coffee. Producing a cup of coffee takes 1 hour of labor, and producing a cookie takes 5 hours of labor. So we can use that to fill in this table here and figure out how many combinations of cookies and coffee can be made. So if we spend all of our time making cookies, that means we're going to have 200 hours to make cookies, and each cookie takes 5 hours to make. So we can just go ahead and divide those 200 hours by the 5 hours it takes to make each cookie and say that we could make a maximum of 40 cookies and 0 cups of coffee. If we make 30 cookies, each cookie takes 5 hours. That means we're going to use 150 hours of labor for cookies. That only leaves 50 hours for coffee, and each cup of coffee takes 1 hour, so that gives us 50 cups of coffee. We can go back over here. If we spend half of our time making coffee, we have 100 hours to make cookies. 100 divided by 5 gives us 20 cookies. And if we spend 10 hours making cookies, if we make 10 cookies, those 10 cookies take 5 hours each, or 50 hours total, for 150 hours left to make 1 hour cups of coffee. And if we spend all 200 hours making coffee, we can't make any cookies. So that's how you'd want to fill in that chart. The next thing you want to do is go ahead and graph your production possibilities frontier. And you can draw it or do it any way that you like. I'm going to go ahead and use these inserted shapes to make my production possibilities frontier. And so I'm going to go ahead and straighten that out. And I want to put my 2 axes together. And it doesn't really matter which side has cookies on it and which side has coffee. I'm going to go ahead and just put coffee down here. And format it the way I like it. And then I'll put cookies up here. And then I know I'm going to want from 0 to 40 cookies and from 0 to 200 cups of coffee. So I'll go ahead and put more boxes, more labels on my chart to show the 40 cookies, 30 cookies, 20 cookies, and so on. So I'll put that right here. And just fill out my axes that way. And you know, with this stuff, it's not necessarily about being super precise in terms of scale, as long as you get the sense of what's going on, what the trade-offs are, right? That's one of the big ideas from this section, is this idea of trade-offs, this idea that we are giving up some number of cookies to make more coffee, or giving up more coffee to make more cookies, and that we're getting that idea of opportunity cost, of making sure we make the most of our precious or scarce resources, and that we're kind of having a sense of how technology and distribution affects those things. So now I've got my scale, and I know I'm going to have the option of either making 40 cookies and no cups of coffee, or 200 cups of coffee and no cookies, or any combination between the two. So I'm just going to go ahead and insert a line from those 2 points. So there's 40 cookies and no coffee, and 200 cups of coffee and no cookies. And I'm going to format that line the way I like it. And that gives me my production possibilities frontier. Now the next part says to draw a point that is impossible to produce and label it A, draw a point that is inefficient, label it B, and then select a point where you want to produce and label it C. So I'm going to go ahead and continue to insert these shapes. I'm going to put my point A right here. And I'm going to format it a little bit differently so it stands out. And label it A. There we go. That is an impossible point. It's beyond the production possibilities frontier, right? Oops. Now I'm going to do another point, and I'm going to put it under the production possibilities frontier and label it B. That would be an inefficient point. So maybe I want it to be 10 cookies and 50 cups of coffee. That would be pretty inefficient, right? The next point I want to do is I want to have my point C be a point that I like. And I'm going to make it be a lot of coffee and a little bit of cookies. So my point C is going to be 10 cookies and 150 cups of coffee. That would get me going. And that's my choice. And that's one of the points of this, right? Any point along that PPF is efficient. If you don't like cookies, you could do all coffee. If you don't like coffee, you could do all cookies. That's it. Pretty straightforward, right? So that is the graphing portion of the midterm. So now let's take a look at some of the multiple choice problems that people had questions about. Okay, so one of the questions on the multiple choice problem people had questions about was number 6. Number 6 says a good that has very hard to find inputs would have. And the first key here in this question is this word inputs. If we're talking about hard to find inputs, we're talking about elasticity of supply. If a good has hard to find inputs, that's going to make it hard to produce more of it as the price goes up. So that's going to be very low price elasticity of supply. Even if the price changes a lot, the supply can't change because it's hard to find inputs. So that's number 6. Scrolling down, I think most of these were kind of straightforward. When prices fall, We expect consumer surplus to increase because more consumers enter the market and because the consumers that are already in the market are going to face lower prices. Their willingness to pay stays the same, right? That demand curve stays the same, but the prices get lower. That is going to increase that consumer surplus. And then I think the next one that people really had a lot of questions about was the problems like this one. So this is the problem with the wage graph. So this graph depicts the market for labor, and we want to use it to answer these questions. So the first question is pretty straightforward. What is the current equilibrium wage? Well, that's going to be the wage where labor supply is equal to labor demanded, and that is wage 3. Boop. How many people want to work at wage 4? Well, at wage 4, labor supplied to the market, people who want to work, is 150 workers. So we just go ahead and follow wage 4 over to how many people are willing to supply their labor to the marketplace, 150. What effect would a minimum wage set at wage 2 have? Well, if the equilibrium wage is wage 3 and the price floor or the minimum wage law is set at wage 2, that's not going to have any effect, right? So if I'm already paying you, say, $10 and the minimum wage is $8, that's not going to change how much I pay you. So it's going to have no effect on the labor market. Does that make sense? The next question, question 21, looked at the market for soybeans. So we have the domestic market for soybeans, domestic demand, domestic supply, and then we have a couple of different prices here. Without trade, the domestic equilibrium price is given where demand is equal to supply. That's $4. With the world price of $6, what will the US do? If the world price is $6 and our domestic price is $4, we are going to export. You can also see that because at that price of $6, the quantity supplied is greater than the quantity demanded. So firms are going to want to produce a lot more than domestic consumers want. So we're going to see the US export. Not only that, they're going to export the difference between the quantity supplied and the quantity demanded. So if firms are selling 750 soybeans and domestic consumers only buy 300, 750 minus 300 gives us an export of 450 soybeans. So the US will export 450 soybeans, the difference between 750 and 300. If the world price is $2, now we're going to see the US import because quantity demanded is much higher than quantity supplied. Domestic firms only want to make 300 soybeans or produce for the market 300 soybeans. Meanwhile, domestic consumers want to buy a lot more soybeans. So now import is going to be the difference between the quantity demanded and the quantity supplied at that world price. So we're going to see the US import 450 soybeans. 300 will be made domestically by our own producers here in the US, and then the remaining 450 to get us up to that 750 is going to come from abroad. If the US goes from a closed economy to fair trade and the world price is $2, what are the welfare effects? So if we go from being here at $4 to being here at $2, what are the welfare effects? Well, we're going to see a couple of things, and I'm going to show it to you on the board. So let's pause and take a look at that. So here you can kind of take a look at a big version of this market and see, kind of capture what the difference is, what the effect is of opening up to free trade. So if we think about the closed economy, then we're stuck with our domestic price, right? We're stuck with the price that our domestic producers can give us. So that is that domestic equilibrium, let me get a good pen for this, of $4, right? If the world price is $2, then we can see the effect of moving from a closed economy to an open economy. So at $4, we have consumer surplus here and producer surplus here, right? That's without any trade. Now, with free trade, we're going to see consumer surplus based on that same area below the demand curve. But now the world price prevails. And so consumer surplus gets much bigger, right? Now consumer surplus includes everything that we had before plus this entire section. So we see an increase in consumer surplus. Producer surplus, on the other hand, gets smaller. A lot of that producer surplus goes to consumers because consumers now face lower prices. We also see a lot of imported goods, so these domestic suppliers are taken out of the market. So consumer surplus is going to get a lot smaller. It's now going to be based on this new world price and the original supply curve. If we want to look at the effect on total surplus, we can see how initially total surplus was the area below the supply curve and above, or below the demand curve and above the supply curve. But now consumer surplus and producer surplus added together is this much larger area, right? It now includes this area too. Those are the gains from trade. So total surplus goes up. So if we want to look at what happens if the US goes from a closed economy to fair trade and the world price is $2, we're going to see bigger consumer surplus, smaller producer surplus, and larger total surplus overall. Okay? The next problems that people had questions about are 23 and 24. 23, a tax on a luxury good will tend to have a small or large deadweight loss depending on the price elasticity of demand. So we have to think about how we think about luxury goods first, right? So luxury goods are goods that we don't need, so people can be really responsive to a change in price. So we're going to expect the price elasticity of demand to be really high because consumers can change their behavior. If consumers can change their behavior, they can avoid that tax, and that's going to increase that deadweight loss. So a tax on a luxury good is going to tend to have a large deadweight loss because the price elasticity of demand is high, right? We tax a luxury good, consumers select away from it, we see a greater decrease in that quantity consumed, and that's where that deadweight loss comes from. Does that kind of make sense? Let me show you the beginning of 24, and then I'll do a graph for 23 and 24 together. 24 looks at this graph, and we have to calculate the consumer surplus, producer surplus, and then the effect of a $50 tax. And this is a great example of what happens when you tax a luxury good. This is the market for watches, and you can kind of already see how the tax reduces, it cuts that quantity in half and gives us a really big deadweight loss triangle. So let's go take a look at that, and that'll really combine the answers to both question 23 and 24 together. Okay, so for the two questions about the effects of, so we're looking at two tax questions, the effect of a luxury tax on deadweight loss and the market for watches. So let's set up our market. We've got our quantity and our price, and then we have our supply and demand curves. There we go. And supply. And when we're talking about calculating the effect of a tax or calculating welfare effects, it becomes really important where our demand curve and supply curve cross. So supply crosses at 0, demand curve crosses up here at 100, the equilibrium price is $50, equilibrium quantity is 100, and then we also have these other lines built in that are going to become useful to us later on with 50 watches, $75, and $25. And so we could go through and calculate all of these things individually. I only ask you to calculate, I think it's 4 different things, but basically it's going through and calculating the consumer surplus without a tax, and then imposing a tax and determining the price that buyers and sellers face, and then looking at the welfare effects. What's the effect on deadweight loss? What's the effect of tax revenue? And this leads back to, if we consider this tax on, say, fancy watches, we can see how this could be considered a luxury tax that has the same kind of effect that we're talking about in problem 23. So let's start out with the consumer surplus, producer surplus, and total welfare or total surplus without the tax. So in equilibrium right now, we have a price of $50 and a quantity of 100 watches. Consumer surplus is going to be the area below the demand curve and above the price line. So that's going to be a triangle with the area 1/2 of $50 times 100 watches, or a triangle with the area of $2,500. Producer surplus is the same, $50, right? 0 to 50. One-half of $50 times 100 watches gives us 2,500. Now, total surplus is consumer surplus plus producer surplus. So we can add these up to get $5,000. Or we can look at this area of this much larger triangle beneath the demand curve and above the supply curve, which has an area of a height of 100 watches and a base of $100, which will still give us $5,000. That's not that I asked for it in the problem. All I asked for you guys to find was consumer surplus. The next thing we want to do is impose a tax. So it's going to be a $50 tax, and it's imposed on producers. But we know from all the conversations we've had about taxes that it doesn't matter who you impose the tax on. So we're going to see that we can shift the supply curve up $50 until you get to the point, or you can just see here, this is $50 between the price that sellers get and the price that buyers pay. That's going to be our tax. So our $50 tax on revenue is going to mean that now buyers pay, the price that buyers pay is $75, and the price that sellers get is $25, right? So they used to have an equilibrium price of $50. Now sellers get $25, buyers pay $75, and $50 goes to the government, which means the tax revenue is this rectangle here, right? So if we go through and want to calculate the welfare effects again, now that we have a tax, we can do that. We can look and see that. Let me make sure I'm all in frame here. There we go. We now have a consumer surplus, a producer surplus. We also have tax revenue and total surplus. So our tax revenue is going to be based on the area of this triangle, of this rectangle. So the tax revenue is going to be, you can also just think of it, it's a $50 tax for 50 watches. So it's going to be $50 times 50 watches, or $2,500, right? That's a lot of tax revenue. The consumer surplus and producer surplus are both going to get smaller. Consumer surplus is now the area below the demand curve and above the price line. So that's going to be a triangle with a height of $25 and a base of 50 watches, which is going to give us a revenue of, or a consumer surplus of $625. Producer surplus is the same, right? $25 times 50 watches, sorry. 25 times 50 divided by 2 equals 625. And so our total surplus is consumer surplus, producer surplus, plus tax revenue. So if we calculate our total surplus, it's going to be 625 plus 625 plus $2,500. Right, which gives us $3,750. Let's do that. The difference between total surplus before and total surplus now is the size of that deadweight loss, right? And that's this triangle here. So if you wanted to find the size of the deadweight loss, you could just calculate the size of that triangle that has a base of $50 and a height of 50 watches, which is going to be $1,250. Or you can say, well, the old surplus was $5,000. The current surplus is $3,750. The difference is that dead weight loss. Do you see that? Kind of. So when we think about a luxury, what we're thinking about is a good that people can avoid easily. And if watches are considered a luxury, then that's going to be something that people can avoid easily. If the price goes up, if there's a tax, people are going to avoid that tax and try to not spend it. And we're going to see a really big reduction in the quantity exchanged, right? We're going to see a big change, and that's going to give us this big deadweight loss, right? So if we look here, the deadweight loss is bigger than consumer surplus, bigger than producer surplus, and it's half of the total tax revenue. So when we think about whether a tax is successful or not, we can think about, well, taxing necessities can harm low-income households, but taxing luxuries really puts a lot of deadweight loss into the system. So that's another way of thinking about it. Okay? And that leads into the last question pretty easily, which says, hey, what does the size of tax revenue depend on? It doesn't depend on the original price or the number of other taxes. It depends on the size of the tax and the elasticities of the good. So hopefully that helped answer some of your questions. If you have other questions, let me know. Otherwise, I'll see you all next time. Thanks.